So, um, going here, and we're going to type in Notepad here. Okay. All right, and the reason why I'm doing that, because remember, when I have my drawing pad in front of me, I have to push back my keyboard, and the keyboard is now underneath, okay, the actual top of the desk, because it actually has a little drawer that pulls out, and the keyboard is on that little drawer. All right, so whenever you see me do that, that's why. And I use um, the on-screen keyboard a lot, especially when I'm laying in bed and have the mouse next to me. I normally have a Bluetooth or wireless mouse, okay, which isn't normally Bluetooth, is wireless, but I haven't, I haven't gotten a new one in a while. I haven't had one, and I normally would lay in bed and be able to control my PC. Now, anytime, like, for some reason, uh, my streaming stuff, okay, like Netflix, Disney, YooHoo, which obviously is now part of Disney, um, they they have a serious issue for some reason to be able to go to the next video. So I can't just lay down in bed and relax because I always have to get up for some stupid reason because the video won't go to the next one. Okay, and Disney slash Hulu, when I'm watching like American Dad or something like that, is notorious for that. Okay, so now, okay, so you are a person, okay? All right, and you are the data, okay? Now, you need to get from a source, which is where you are right now, to a destination, okay? Now, this is done by mail, okay? And it's funny because if I get a return message, which is why I have my source address, okay, from a post office, and then my destination, okay, address. Now, the source is important because when I when I put the address on here for the destination, okay, if something happens with that delivery, okay, it's going to go back to the source address that I put on the envelope to say, hey, this traffic or this letter was not routable, okay? And if you don't think mail gets routed, it does, okay? All right, the whole concept, okay, of encapsulation, doing a source address, destination address, source MAC address, destination MAC address, okay, is the concept of how mail is delivered, okay? And if you think of a packet as an envelope, you'd be right, okay? All right, but if this could not be delivered and I do not have a source address, okay, what happens? I have no idea and it gets thrown in the trash, okay? But with TCP/IP, I cannot even send a packet out my interface without the source address, the destination address, that's IP by the way, IP address, and the source MAC address and the destination MAC address. Matter of fact, if anything of those are missing, you're going to get a message either on your console or in the background, okay, that says literally, okay, encapsulation failed or something like that, okay? Meaning that the encapsulation could not be completed because you're missing one of those four elements, okay? Now, with our analogy here, okay, you are the data. So how are we going to get you to your destination? Now, your source is home, okay? All right, that's your source. Your destination, Taco Bell, okay? Now, you need to be able to travel on the wire. What is the wire? The wire is the road. And you need to be encapsulated. What's your encapsulation? Your car. So you get into the car, which is simulating your electrical signal, okay, and you fly down to the Taco Bell. Now, the time it gets you to get from here to Taco Bell, okay, is your time of trip. And as you return, this is your return time of trip, okay? Think of it that way. And the faster you go, the more that you will be considered bandwidth capacity. Okay? Alright, now these are just words I'm making up, so just bear with me. Okay, so now, if that's the case, here's your house. Oops. Let's come on. Come on. Here's your house, okay? And this is your source. Okay? And Taco Bell is over here. Okay? Alright? Alright, we'll even have a little chimney come out here and smoke for, the cooking of tacos. But nonetheless, alright? Okay, so you get in your car. Alright? And, we got a nice little, whatever. Alright? And now you are in the car. Okay? The car is your electrical signal that is going on a wire. The road is your wire. Okay? So I want you to think about this. Alright? If that's the case, who built the roads? Well, that's an interesting thing, because in order for you to get to this destination here, you need a path to get there. Okay? Without a path, right? How do you get there? So, think of a router, okay, as your points from A to B to build these paths. Or think of it as a traffic light, okay? Traffic light sits here, all right? 1, 2, 3, right? It sits there, and at every traffic light, it gives you the ability to route to a different path, okay? Or this is network 1, this is 2, and this is 3. At that intersection, it connects the ability to move from one network to another, okay? That's the job of a router. That's why I put it here at this intersection, okay? All right, here's your network. All right, here is network 2. All right? Now, that's a router. Its job is to route packets from one network to another. Okay? So, here's the thing. You cannot go from one network to another without a router, which is why we had to create the interface VLANs on our switch. That is the router. Okay? All right? We had to actually type in IP routing in order for the route engine to be enabled. Okay? Now remember, all right, it's not the switch doing this. It is literally a routing engine. Okay? Cisco took a router and put it inside the switch, making it a layer 3 switch. Okay? Now, let's say you are in a parking lot. Okay? One car pulls in here, one goes in here. Okay? All right? What does this remind you of? When you pull into the parking lot, okay, every other car that you are able to pull up next to or in that facility, you can communicate with, okay, as long as you're not isolated by VLANs, or I should say cones, to stop you from walking over to the next actual host or car or PC or whatever. Okay, so think of the parking lot as your switch, where everyone can move together, drive together, not drive together, but drive separately to this location and be able to communicate with you. Okay, all right. Think of your router as a traffic light. All right, okay, and think of a checkpoint. Okay, where you have your police car. All right, with your sirens here. All right, flashing out lights. Okay, all right. This checkpoint is your firewall. This checkpoint, as you pull up and talk to the officer, you get to determine, I'm sorry, he gets to determine whether you are allowed or denied. Okay? Alright? So your firewall is a checkpoint, the traffic light's a router, and your parking lot's a switch. Okay? Alright, so that's an analogy. Alright? Now, what does that mean? By basics, okay? Switch 1 is connected to this PC and this PC, okay? And internally, inside our house or our building or our office, all our devices on our network, okay, is able to communicate with each other, okay? And their default gateway, okay, is going to be the IP address of the router, okay? Why? Because here's the thing about a router. Only one interface at a time can be in a network, okay? Now, we're going to break that rule later on, okay? But for now, if you try to assign this interface to a network that's on the same interface as this one, TCP is not going to allow you. TCP/IP is not going to allow you to do this, okay? Because that defeats the purpose of a router. Okay, what's the purpose of trying to use a router to route traffic from one network to the same network? It is ridiculous and pointless to have a router to do that. Okay, now you can bridge interfaces together, which will break the rule, but still, every interface needs to be on a different network. So, this is what is considered a local area network. Okay, it's a LAN. All right, we have control of all this, but our default gateway is this interface here, whatever the IP address is there. Okay, and we will use this if we want to go outside our network. Okay, all right. Now, if we're going outside our network, what are we doing? We are routing traffic from one network to another. Now, this router here is connected to the internet. Okay, whatever ISP you're using, and this IP address is going to be a public IP address to the World Wide Web, okay, which is network 2, all right, and this is network 1, okay, all right. Anything going past this router, meaning that traffic comes in this interface and is switched to this interface, okay, beyond this interface that you still control, okay, past this interface, you're not in control, okay. That data is going to wherever it's going, to whatever server is sitting here on the network, or to an actual router, okay, that you also control, that is another site. Okay, same thing. Okay, all right. Routers are notorious as a necessity and a need in order to get from one network to another. Okay, it is your traffic light. All right. Now, based on your routing table, that routing table, okay, will forward that traffic. Now, here's an interesting thing, okay? All right, if you ask me what's the difference between a firewall and a router, okay, so, router, okay, we're kind of drawing bricks here, all right? Firewall, okay? So, firewall 1, router 1, okay? Now, a router can route traffic, so can a firewall, okay? All right? A router can deny traffic, so can a firewall, okay? A router can also allow traffic internally from the internet inside your domain, so can a firewall. Now, here's the difference with a firewall and a router. The concept of a router is to create paths and routes to your destination. So, by default, a router is going to allow everything in. Okay? We don't have any deny of traffic, okay, by default. And if we do want to deny traffic, we need to configure that router to deny traffic. Where a firewall doesn't allow any goddamn thing in. All right, it's just like, dude, everything's denied. Okay, in order for traffic to go through the firewall and be allowed, you need to create a statement to allow that traffic to come in with a firewall. So those are the the two biggest things. But you got to understand, as a firewall is being a checkpoint, okay, your configurations is allow or deny, okay, where in a router, it's all allow and then deny, okay, because by default, this denies everything, okay, where this one allows everything. All right, it would be annoying as hell to create a device to route traffic that denied everything. You want it to allow everything by default, okay, and then make your deny statements later on because you want these roads to be reachable, okay. Think about a highway, okay, it's like I said before, okay. You got your actually, let's go to a new screen, okay. You got this huge 3-lane highway, right? Okay, all right, 1, 2, 3, 4-lane highway, okay. All right, now, here's the thing. Branch off this highway, okay? Now, you got 4 lanes going, okay? All right, everyone's moving at the same speed, okay? But you get 4 pieces of data at the same time than you would as a regular road, meaning that it gives you the perception that your bandwidth is 4 times its length, right? And speed. Because that's what you're really paying attention to is the speed, not the literally the width of the band. You could care less about that. You want your data fast, okay? So I got a 1 gig link to the house, okay? All right, and at one point this was unheard of, okay? But Fios, hey, they're champions, all right? Verizon made it happen, okay? And look, I can even get even higher. Okay, why you would need that, beyond me. Okay, but still, it's possible. Now, okay, here's the thing. This bandwidth, huge bandwidth, will branch off to other roads. Okay, which will go into neighborhoods, shopping centers, okay, parks, things like that. Okay, all right, and that allows us to come down into a lower pipe. Okay, all right, but the speed to get to here was fast. Here is going to be a quarter of the bandwidth. That part's okay, okay, because we were able to get to this point a lot faster than normal. But remember, okay, that if a firewall was in between these devices, this will be a slow trip. Okay, we don't want that. We want our roads to be available. Now, okay, let's say this road belongs to you. Now you can put your own little firewall here if you want. Okay, all right, and you'll be a little bit of delay getting off the freeway over into this road. That part's okay. Okay, let's say it's not. Let's say this is the infrastructure of the internet. Okay, now, if that's the case, you would expect not to have any firewalls, and that's not really the case. Because remember, all right, as we draw our router to the cloud, okay, until we get to another router that belongs to us, okay, meaning that we own these 2 routers at 2 different locations, 2 different sites, okay, all right, whatever's in this cloud from point A to point B, I have no idea how many routers it's going to transition. Nor do I know of how many ISPs. Okay, all right. I should not want to care to know. Okay, meaning that an ISP's job, okay, is to bring a connection to your location, to hook up to your router, okay, or if you're sitting at home, your horrible Verizon router, okay, and you have no idea how many ISPs it's connected to, because that's his job. Okay, all right. He might be on the far end of the spectrum. This ISP that's providing you internet access, and he needs to go through two more ISPs before he's able to get the traffic to hit the real raw internet aspect. Okay, but you don't know about this. This will just be one cloud. Okay, all right. I mean, you just don't know. Somewhere down the line, it needs to reach another ISP, and that's the job of the ISP, not yours. Okay, it's a different type of routing. All right. So now, with that being said, okay, that is why we need routers. So, as you are learning networking, okay, we're not covering firewalls just yet, okay, nor will it be any time in the near future, but we will get there eventually, okay, once we cover the things we need to cover as far as basic network is concerned. Okay, remember, you got your basic stuff, okay, which is what we're learning now, and then you get farther into the, aspect of advanced stuff. All right, but until you get there, all right, you are learning the basics of networking, and what better way to learn from the beginning than switches and routers? Okay, now you don't have to learn these things if you want to be like security. You can skip all this aspect. Okay, now in the security track, okay, if you want to go down security, your main focus is security aspects as far as security policies of the company if you're going that route, or if you just want to be a firewall engineer, that's fine. Okay, all right, you go right into firewalls. Okay, all right, the concept of you needing to know, which I had a huge thing on YouTube. I was watching this guy talk about one of the things he wish he would have known as a security guy was routing and switching. And guys, I'm telling you, okay, in the 15 years on this planet, okay, I have yet to see a firewall engineer, okay, that can handle real routing and switching. They call us the network engineers. Okay, they're firewall engineers. All right, okay, that goes with Palo Alto, that goes with ASAs, that goes with Fortinet, okay, that goes with Juniper. All right, I'm telling you, I have not met one. Okay, unless he is a route switch slash security engineer, which I am. Okay, I can handle both sides of the spectrum. Okay, but as me being hired as an engineer, they're going to put me in one or the other because I'm always working in large enterprises. So, what does a large enterprise? Well, first of all, what does a small network look like? Okay. I guess that's as far as I can go. Okay, the drawing that I drew before. Okay, PC, switch, server, router, internet. Okay, now, doing basic routing, okay, from a concept of a small company, okay, which has several routers, several switches, maybe 50 employees, okay, you're able to work on that. But, okay, these are the type of networks that I work on and have been for most of my career. Matter of fact, all my career. Okay, so you have a data center. Number one, a data center. Number two, okay, all right, that is on premise. Now, this will actually connect to other data centers, okay, across the globe, depending on how many sites they have. Okay, from those data centers, there are tons of routers, switches, firewalls, VMware, hypervisors, F5 devices, storage devices, okay? And I'm talking like aisles and aisles of these things, okay? So many that it is broken up in aisles like A, B, C, D, 1, 2, 3. And the location of your devices is set in this grid, okay? Each data center is its own size, Okay, uh, I the data centers that I've been a part of haven't been like Amazon data centers, okay, which are phenomenal to take a tour of. Okay, if you ever get a chance, I would recommend it. Just the cabling alone, it's like a well-designed Lego foundation without you tipping over the Legos. It is beautiful. Okay, the huge backup generators, which are diesel, are just that in itself is phenomenal. To look at those bad boys sitting inside or outside the facility and how huge they are. Okay, but nonetheless, okay, coming down from the data center, all right, because this is just a data center. Okay, that's just where your equipment is stored. Okay, now, all right, you're in the office. So from the data center, okay, you got connections, okay, to other data centers. You got WAN connections, okay, going to the other data centers, okay, all right, which what these links will be here, all right, and you have internet connections, okay, so you might even have a MPLS connection, okay, going to other data centers. Who knows? Okay, you might have all three. All right, and yes, I have seen it. Okay, where you got WAN, MPLS, and our internet aspect. Okay, so now that trickles down, okay, to a core switch. Okay, that trickles down to two distribution switches. Okay, all right, and that trickles down to access switches. All right. Now, each data center is going to have this type of scenario, okay? And we call this a campus because nothing's larger from a perspective of connectivity. Now, I'm talking about connectivity volume, by the way, than having a college campus, okay? Because of all the people that are on the campus, all right? But it doesn't mean that their network is larger than somewhere else, okay? Now, okay, this is what we call a large enterprise, okay? A lot of moving parts, okay, a lot of complexity, okay? There are networks that I've been involved in as far as the contract is concerned, and I would think to myself, well, okay, if I could survive in this network, I could survive anywhere. Okay, and that is kind of a misleading aspect or thought process because every network is different and it all depends on what you're doing. Okay, you can have um, a 5-man networking team, okay, all right, working on all the things that needs to be done on a credit card company. All right, now credit card company, something like American Express, you're going to realize how large they really are. Okay, they have multiple networks within the same chassis. Okay, via Nexus platforms and VDCs. I think it's VDCs. Where you can actually have multiple VDCs, maybe 4 or 8, and have multiple networks or data centers inside your data center. Okay? All right? This is complex. Throughout your entire data center, you got firewalls. Now, I want you to picture something here. Okay? All right? As data comes in to your router, okay? Into your data center. Okay? All right? Here, you got a router, and then as you go through your data center, you get a firewall within your data center. As you go to another part of your data center, we'll make these squares or domains, okay, you got another firewall, okay, all right, and coming over to this part, okay, there's another firewall, okay, so wait a minute. Not only do you have 3 firewalls within your data center before you even leave the data center as far as a traffic egress perspective, but you got natting too. Meaning that as you're coming in on this interface, natting the traffic here, natting in here, and natting in here, and you're like, oh my God, I got 3 NATs that I gotta go through. This makes things complicated. Okay? Alright? Now, you are at a hospital. Okay? Your data comes in, okay, hits your firewall here, okay, then hits your router to send to multiple paths to your hospital. Now, there is a device sitting here, some type of scanner. Okay? And this scanner does not meet HELPA, okay, did I say that right? Compliance or hospital government compliance. So what do? You put a firewall here so you can use a scanner. All right, that stops the scanner from making things vulnerable. Okay, someone attacks attacks the scanner. That's fine, but that's as far as it gets. Okay, because the firewall is going to block it. All right, guys, I've seen this. Okay, I'm trying to figure out why I can't get to the scanner, and underneath the desk, all right, where cables just happen to be, for some reason fed underneath the actual desk, someone's desk. There is a Juniper firewall just sitting there for whatever reason. And I'm going to tell you the reason is compliance. And there is firewalls everywhere throughout the hospital. Okay? Now, this particular hospital I'm talking about that I was working on was 100 and some closets. So, trust me when I tell you, it had its complexity, all right, within it. Okay? So, now, from that aspect, okay, you can put firewalls anywhere you want. Okay? Alright? You can use BGP as your foundation routing protocol. Okay? There's nothing wrong with that. No one said you couldn't do that. Alright? When you talk to other engineers, they'll be like, that's bullshit. No one will ever do that. And that's not true. Our routing protocol has its benefits. Okay, I told you in my career I have seen RIP used in a satellite topology. Okay, all right, and it's still being used today. All right, the chances of you running around RIP protocol is far from none, but that's all because of the stigma that engineers put on RIP and why they would never use it and demand to re-engineer their routing protocol if they ever see RIP. Okay, guys, that's just bad. All right, the last thing I'm going to do is come into your organization and just redesign the routing protocol. I'm going to fix the problems that you want and leave RIP alone. Okay, because it's not my network, and my personal opinion of RIP has no merit to my services to you that I'm providing. Okay, so I wanted to have a discussion of where things fit and why we use them. Okay, before we get into routing as a configuration and theory aspect. Okay, but this is actually part of the one theory. Okay, this video was necessary. So, as always, be strong, be determined, be Cisco.